the second homework. This is the next section. This is section 4.2. So this is chapter 4.2. And then this is going to be chapter 4.3. And then this is the derivatives. So on page 267, 1 through 47 odd, and 51. Okay, that's the homework. Now, the first part is really, this part right here is just a review of something we've done before in pre-calculus and algebra 3-4. So, but we do need to review. And then the second part is taking derivatives of logarithms and exponential functions. So this lesson's going to be long. The homework's not that bad. It's actually fairly short. So that's why if I assign one at a time, then it would take 2 days, and then we'll spend 2 days on this. This is 1 day's worth of homework. So let's start with the first section, chapter 4.2. In chapter 4.2, you're given, well, let's start with problem number 10. This is 10a. Okay, and then you're given ln of a third root of c, all that over ab, and they just want you to expand that using logarithm rules. Obviously, this is a quotient rule, so this is going to be ln of third root of c minus ln of ab, and this really means ln of c to the 1/3 minus, okay, ln of a plus ln of b. And of course the power comes to the front, so 1/3 of ln of c minus ln of a minus ln of b. That's the end of that problem. So all we did was we expanded this logarithm. Alright, the next one is compression, which again, we've done this before. Let's go to 14. Is 1/2 log of x. When you don't see log a base, it's automatically 10. When you see ln, the base is e. And then minus 3 log of sine of 2x plus 2. And here they want you to go backwards and compress. Of course, this ends up as an exponent, and this ends up as an exponent. So this now looks like a log of x to the 1/2, which is same thing as square root, minus log of sine of 2x to the 3rd plus 2. Okay, so now this minus means division in logarithms, so log of square root of x, all that over sine of 2x to the 3rd plus 2. Okay, if you want to, you can also write this as a log of square root of x, all that over sine cubed of 2x, means the same thing. Okay, that's 2 of these problems, so let's do a few more. Oops. Let's do a few more before we leave this section and actually get to the calculus, which is taking a derivative. Okay. Now, the next one I'd like to do is number 18. Okay, I'm on page 261. This is number 18. Number 18 says ln of x squared is equal to 4. And they want you to solve for x. So, this is the same thing as base e, so that means e to the 4th is equal to x squared. Okay, that's, well, you know what, there's an easier way. Let's do it this way. I don't like it that way. Just put the 2 out in front. Ln of x is equal to 4. Okay, and when you solve, you get ln of x is equal to 2. And then this is e to the 2nd is equal to x. Okay, so now if you went that path, okay, you're going to get e to the second is equal to the x. Now when you go this way, the way it initially started, I want to get plus or minus square root of e to the 4 is equal to x. Of course, square root of that is going to be plus or minus e to the second is equal to x. So, this doesn't look quite like that one. So which one is the correct answer? Well, correct answer is this right there, okay, for two reasons. One, you can put a negative in place, negative e squared in place of that, and then the square will get rid of the negative and you'll get the correct answer, okay, or the positive. Now, because this is squared and this here is not, x is not squared, you're only going to get a positive answer. But this is same as that, so this only gives you the half of the answer, so this is the correct answer. Okay, so gotta be careful when you're squaring things. Gotta be very careful. Okay, so let's go to the next one. Let's look at 22. 22, you have log base 10 of x to the second plus log base 10 of x is equal to 30. Right, so first of all, that means multiplication logarithm, so this is log base 10 of x to the second times x is equal to 3. This really means 10 to the third is equal to x to the third. Okay, so that means x is equal to 10. Alright, let's work our way down to number 26. So we have exponential functions now. So we have 3 to the x is equal to 2. So if you want to solve something like this, you will have to take ln of both sides. So ln of 3 to the x is equal to ln of 2. Okay, which means x comes to the front, so you have ln of 3 is equal to ln of 2, and then my x is equal to ln of 2 over ln of 3. And that's my final answer. You want to leave it there. You don't want to turn them into decimals because decimals are approximations. These are exact answers. Okay, let's get rid of that. And let's move on because I want to get to the next section, which is the calculus portion of it. So this is a quick review of algebra. So let's do a couple more problems. Let's look at 30. We have e to the x minus 2x e to the x, and we're solving for 0. First thing we're going to do is we're going to try to factor out what we can. Factor out e to the x, that will leave me the 1 minus 2x inside the parentheses, that's equal to 0. So each factor equal to 0, you're going to get e to the x equal to 0. 1 minus 2x is equal to 0. So when is e to the x 0? Well, that's something you should know. E to the x looks like that. So therefore it never crosses the x-axis. That's why we get nothing from that. Whereas here we're going to get x is equal to 1 over 2. And there it is. That's your solution. Alright, one more problem in this. And then we'll go on to the next section, which is number 32. Number 32, you have e to the 2x minus e to the x is equal to 6. Okay. And they even give you a hint on this, but we'll take the hint. Okay. If you rewrite this, this is e to the x quantity squared minus e to the x minus 6 is equal to 0. And they tell you that u is equal to e to the x. So if you're going to let u is equal to e to the x, this becomes u squared minus e to the, well, minus u minus 6 is equal to 0. And this is quadratic, and therefore you can factor that. This now turns into u, and then factors of negative 6. So it would be negative 3 and positive 2 will work. Okay, that means u is equal to 3 and u is equal to negative 2. But we're not solving for u, you're solving for x, so we're going to substitute that back in. E to the x is equal to 3. and e to the x is equal to -2. Okay, so where is e to the x curve -2? Come on, e to the x curve looks like this. It's always positive above 0. So this is nothing. If you try to take a logarithms, you can do that way too. You can't take a logarithm of, or ln of -2. Right? And then what we have left here is e to the x is equal to 3. Then we're going to ln both sides. ln of e to the x is equal to ln of 3. And the x comes to the front, and we have ln of e, okay, is equal to ln of 3. Of course, we should know by now ln of e is 1. Okay, since that is 1, my x is equal to, that implies my x is equal to ln of 3. Okay, of 3. And that's it for this section. This basic stuff, something we have done, should have done in Algebra 3-4, and I know we did in pre-calc when we got to logarithms. So that's it. So let's get to the next section, Chapter 4.3. Okay, derivatives of logarithms. Right. One thing you need to know is, this is the most important thing, is that if y is equal to ln of x, y prime is equal to 1 over x. That is very, very important for you to know. Okay, now I can prove this for you. Take some time out to prove it, and then it'll make this video long. So what I did was I went and I did post a video of this proof, okay, from Khan Academy. So if you want to take a look at that, it's really pretty cool proof. Okay, so you don't have to take notes on it. That's why I posted that. So whatever I'm writing here, you do have to take notes on this. Alright, but I will prove this is the first thing you need to know. And then the second thing is, if y is equal to e to the x, then y prime is equal to e to the x. And I will prove that because it's pretty short. If you know this right here, it's easy to prove this. Okay, this is a longer proof, but it's pretty cool proof. Okay, so let's go ahead and prove this one. Okay, so y is equal to e to the x. What I'm going to do is I'm going to take ln of both sides. ln of y is equal to ln of e to the x. Okay, and then the x comes to the front by exponential rule, so I have ln of y is equal to x times ln of e, and we know by now ln of e is really 1, so I have ln of y is equal to x. Now I'm going to take the derivative of this using chain rule, implicit differentiation, because I can't solve for y, because then I can, but I'll be going backwards. So derivative of outside function is ln, and we know the derivative of ln is 1 over x. In this situation, because it's y, it's going to be 1 over y. Times the derivative of the inside, which is y prime. And of course, the derivative of the x is 1. Okay, so my y prime is equal to y. Well, what does y stand for? Well, y originally stood for e to the x, so my y prime turns out to be e to the x. And there it is. Okay, so two most important rules for this section, logarithms. If y is equal to ln of x, then y prime is 1 over x. Memorize it. And then second one, if y is equal to e to the x, then y prime is equal to e to the x. Okay. Now, this is why we use ln's on calculus rather than other bases. Okay, I'll show you why in a quick second. Okay, so if you have a, let's say, log base 10 of x, and if you want to take the derivative of this, okay, then you have to memorize another formula. And the proof is given in the book, but the easiest way to do this is actually just convert everything into ln by change of base formula, which is problem number 40 in the last section where you have to prove. It's the same thing as ln of x over ln of 10. That's change of base. Change everything to ln. Okay? And then we can take the derivative of this. 1 over ln of 10 is just a coefficient. It's just a number. So all we're doing is taking the derivative of ln of x. So y, oops, not y prime yet. Okay, that's still a y. Okay, so my y prime is 1 over ln of 10, and ln of x, derivative of that is 1 over x, and there it is. So if you have a function like this, y is equal to ln of 5 of x, then y prime, okay, we'll rewrite this as ln of x over 1 over, over ln of 5. So y prime is going to be 1 over ln of 5, because that's just the coefficient, times 1 over x. So if you want a formula, okay, here it is. If you want to memorize another one, I would just take ln of both sides before you do anything. If y is equal to log base b of x, then y prime is 1 over, y prime is 1 over ln of b times 1 over x. And that is the formula for any other base besides that ln. But it's just easier to convert that into change of base formula and go from there. Alright, that's the easiest way to do that. Now remember, you cannot take logarithms of negative numbers, okay? You can only talk, that's because a logarithm curve exists to the right of the y-axis, okay? And same as exponential function is always positive because it exists only above x-axis. Okay, so this is y is equal to e to the x, and this is y is equal to ln of x. Alright, so let's do some problems, examples, and that'll be end of the lesson. Okay, make sure you check out that ln proof by Khan Academy. It's about 12 minutes. Okay, so I didn't want to extend this video 12 more minutes. I know you guys were disappointed. So y is equal to ln of x to the third, and we're finding y prime. Well, whenever you have this 3, you can move that up to the front, so the same thing is 3 times ln of x. That means my y prime is going to be 3 times derivative of ln of x, which is 1 over x. Okay, let's do number 6. Let's say y is equal to ln of 2 plus rad x. Well, I am on page, for those of you that are using as a reference, page 267. Okay, so these are easy. Okay, so what is y prime? Okay, first of all, we're going to take the derivative of that, which is 1 over 2 plus rad x, times, we're going to take the derivative of the inside, because we're using chain rule. The derivative of ln is 1 over whatever this garbage is. Okay, times derivative of 2 is just 1, and then derivative of square root of x, that's really x to the 1/2. It's going to be 1/2 x to the negative 1/2. You can leave it right there, or you can simplify it. You don't have to. You leave it right there. Okay. All right. Let's go on to number 8. Number 8, I have a y is equal to ln of x, and we're taking the derivative of this. Well, we'll take the derivative of the outside function, which means 1 over this, which is ln of x, times derivative of the inside function, which is 1 over x. Done. See how easy it is? That's why I had to cover 2 sections. Okay, and then next one is 14. I have a y is equal to sine squared of ln of x. Okay, now I'm taking a derivative of this, but I have to use a chain rule. What's my outermost function? It's the square one, so I got to take the derivative of the square function. This is the same thing as those. Some of you were still confused on the midterm, that you could not understand that if I put a square here, this goes all the way on the outside. But if I put the square in the x, it's totally different. Okay, the outermost function is that. That's going to give me 2 times sine of ln of x to the 1 power times the derivative of the inside one, which is cosine of ln of x, times the derivative of the innermost one, which is 1 over x. And that's it. Okay, so let's clear that. Okay, let's get to number 16. so 16, I'm on page 267, still with logarithms here. Okay, I have a y is equal to x times log base 2 of x squared minus 2x raised that to the third power. Alright, like I said, you can memorize a special formula for other base besides ln, but you know what I would do? This part right there, I would convert that to ln. So x times, I would go ln of x squared minus 2x, all that over ln of 2. That's what that is. Okay, that's what that is. And let's clean it up just a little bit more. This is x times 1 over ln of 2. That's just a number, times ln of x squared minus 2x. All that raised to the third power. Alright, now let's take the derivative of this. Okay, obviously this is a product rule because first times derivative of second, so first times. When I go take the derivative of this, my outermost function is my cubic, so that I'm going to get 3, all that times 1 over ln of 2 times ln of x squared minus 2x raised to the second times, now I'm going on the inside, but 1 over ln of 2 is just a coefficient, so I'm just going to leave, it's just a number, I'm going to leave that out in the front, times derivative of the inside, which is 1 over x squared minus 2x, okay, and that's just the derivative of ln. Now I have to go inside of that, take the derivative of that, which is going to give me 2x minus 2, okay, close that. That's just the first times derivative of the second, plus the second, which is brackets 1 over ln of 2 times ln of x squared minus 2x, okay, raised to the third power times derivative of the first, which is 1. Okay, for those of you that really love algebra, you can go ahead and simplify that if you choose to. Okay, let's do 18, because I think you might get confused when you get something like this. So y is equal to, I wasn't going to do this, but I think I better do it. So log of x over 1 plus log of x. So what you want to do here is, again, change everything into ln's, because we want to work with ln's because they're easy. The top one here, that is really ln of x over ln of 10. All that over 1 plus ln of x over ln of 10. So you might want to clean this up a little bit using algebra before we take the derivative of this. You don't have to, but you can, but I'm going to do that. So this is really 1 over ln of 10 times ln of x, all that over, this is common denominator is ln of 10, so I'm over ln of 10 plus ln of x, all that over ln of 10. And then this gets flipped, and the ln of 10 ends up on the top, and this ends up on the bottom. The ln of 10s will cancel out, so this simplifies to ln of x, all that over ln of 10 plus ln of x. Okay, so now we've done all the algebra. Let's take the derivative of this. Okay, I have to use a quotient rule, denominator, which is ln of 10 plus ln of x, times derivative of the numerator, which is 1 over x, minus the numerator, which is ln of x, times derivative of the denominator, ln of 10, that's just a number, so that becomes 0, and then the derivative of that is going to give me 1 over x, and all that's going to be over denominator, which is ln of 10 plus ln of x, and all that is squared. Okay, so now the easy ones, like number 20, where we have to take the derivative of e to the x. Okay, y prime is equal to e to the negative 5x squared. Okay, remember, if y is equal to e to the x, then y prime is equal to e to the x also. Okay, so therefore, but this one I have to use chain rule because my outside function is the e, and my inside function is that. So that means y prime is going to be e to the negative 5x squared times the derivative of the negative 5x squared, which is negative 10x. We are done. Okay, at least with that problem. So not done with everything yet. Right. So if few more. Like I said, the lesson itself is long, but the homework is not that long. It's not that bad. So I'm on page 267. Okay, I am going to do number 34. Okay, this is d of dx, and the function is given to us as ln of a square root of x minus 1. The radicals on both x minus 1 over x plus 1. Okay, so before you do anything, we want to do some algebra. This is same thing as ln of a square root of x minus 1, okay, minus ln of square root of x plus 1. I haven't done anything but algebra. We'll keep doing some more algebra here. This is same thing as 1/2 ln of x minus 1, okay, minus 1/2 ln of x plus 1. And if you want, we could have taken this out to begin with and moved the 1/2 to the outside. That's just fine. Okay, that'll probably even faster. So let's go ahead and pull that outside. That will give us dx 1/2 ln of x minus 1 times ln of x plus 1. So you could have just as well jumped from here to here using algebra because that's square root. Okay, now it's easy to take the derivative. 1/2 is just the coefficient. Derivative of this is really, I'm going to go outside, which is 1 over x minus 1. That's the derivative of that. But derivative of the inside is really 1. Minus derivative of ln is going to be 1 over x plus 1 times derivative of the inside, which is 1. And that's it. And you don't have to put the 1s there. Right? You can leave that like that. Alright, let's do number 38. Okay, you'll see why logarithms are useful when you're taking derivatives of really long functions. So this is number 38 on page still 267. Okay, and yeah, y is equal to sine of x times cosine of x times tan cubed of x. All that's going to be over square root of x. Alright, now you can take the derivative of this as is. You have to use a quotient rule, product rule, and then you have a chain rule up here because tangent is cubed. Or you can use what's called logarithmic differentiation. We can ln both sides. Okay, so let's ln both sides. I get ln of y on the left side. When I ln the right side, and we're big boys and girls, we can do this in our head right now. I'm going to have ln of sine of x times cosine of x times tangent cubed x minus 1/2 ln of x. Okay, you should be able to actually, I did this in 2 steps. You should be able to do this part also, okay, in 1 step. So let's go ahead and finish that right now. It's the same thing as ln of sine of x plus ln of cosine of x, because I'm using a product rule, okay, and then plus 3 times ln of tangent of x, because 3 is an exponent, and then I have a minus 1/2 ln of x. Alright, now I'm going to take this derivative implicitly. So on the left side, derivative of ln of y is 1 over y times y prime. Okay, and then the right side, derivative of that is, okay, 1 over sine of x times the derivative of sine, which is cosine of x. Okay, plus derivative of this, derivative of ln is 1 over cosine of x times derivative of cosine is negative sine x. And then I have a plus 3, and derivative of ln of tangent of x is 1 over tangent of x, because that's just the derivative of ln, times derivative of tangent x, which is secant squared x. And then minus 1/2 derivative of ln of x is 1 over x. Okay, let's clean this up, and I also have to multiply by that. Okay, get rid of the y, so y prime is equal to, this is really cosine over sine, that's cotangent of x. And this is really negative sine over cosine, which is negative tangent of x. And let's just leave this as is. I'm just going to write that as a 3 secant squared x all that over tan x. Okay, minus 1/2 x, or 1/2 goes on the bottom. So let's put that on the bottom. Okay. Alright, all that times, remember I got rid of the y right here by multiplying both sides by y. Well, what's my y? That's my y right there. I got to put that back in there. Times the y, which happens to be sine x, cosine x, tangent cubed x, all that over square root of x. And there it is. Okay, that is the derivative of that long function. Okay, I want to do a couple more problems, and we'll stop right there. So 42 and 44 on this page. So clear that. So page 267. Let's look at 42. Okay, so they give us y is equal to pi to the x tan x. Well, there's another theorem you can memorize for this, or whenever you see a base, other than, you know, if you didn't have an x, you had, other than e, let's say instead, if you get a pi, if this was a 3, or if this was a 10, whatever, okay, first thing you want to do is, hey, my variables in the exponents, I'm going to have to ln both sides. So ln both sides. Either that or memorize the theorem. I would memorize it. I would just ln both sides. When you ln both sides, left side is ln of y, the right side is the exponent comes down, x times tan of x times ln of pi. Good. Okay, all I did is ln both sides. Now we can take the derivative of this. So chain rule here, 1 over y times y prime. Okay. Well, this is just a coefficient, so I'm just going to move the ln of pi out to the front. And when I take the derivative of this, I have to use a product rule. First times the derivative of second, which is secant squared x, plus second, which is tan x, times the derivative of first, which is that. The only thing that's left is multiply by that. So y prime is equal to ln of pi, all that times quantity x times secant squared x plus tan x. And I do have to go back and multiply both sides by the y. Y happens to be pi to the x tan x. Okay. So basically, if you want another rule, say, let's say y is equal to b to the x. Y prime is b to the x times the derivative of the x, which is 1. Or there's my b to the x. Okay. Let's say y is equal to, we have another function, b to the f of x. Then y prime would be b to the f of x times the derivative of f prime. Okay, that's exactly what we did here. There's my function right there, and that's the derivative of the exponent right there. Okay, and that's let's see. Oh, forgot it. ln of b. Okay, ln of b. Right, because I got to account for that right there. Okay, who wants to memorize all these formulas anyway? Okay, just ln both sides. Okay, and then you don't have to memorize any of those formulas. All right, let's do 44. Similar concept. Okay, this is number 44. And y is equal to x to the sine of x. As soon as I see a variable in the exponent, there it is. Okay, I want to ln, because derivatives of ln are easy. So I'm going to ln the left side. Then when I ln the right side, I'm going to get a sine of x times ln of x. Okay, let's take the derivative of this, which is 1 over y times y prime. And derivative of this, I have to use a product rule. First, times derivative of the second, plus second, times derivative of the first. See how easy it is? And then we just have to multiply both sides by y. So I'm going to get sine of x over x plus ln of x times cosine of x and then we'll multiply everything by y, which is x to the sine of x. Now you don't have to worry about memorizing any formulas. And there's a ton of formulas in this section. You only need to memorize these two. Y is equal to ln of x, then y prime is equal to 1 over x. If y is equal to e to the x, of course you have to apply chain rules for these. Y prime is equal to e to the x. Everything else, you just ln both sides. Okay? Alright, that is pretty much, let's see if there's anything else I need to read. I think that pretty much does it. Okay?